guys, third video. This is going to be intro to angles. You're actually going to learn this in small groups on Friday, but we're going to go ahead and give you a little intro lesson so you are at least a little bit ready for Friday's small group lesson. So you should have 2 pages, intro to angles, cover page with some real world examples, and then this page here. We're actually going to start with this page and then come to our real world examples. You're going to need a glue stick. You're going to need a notebook. Okay, on this first one, kind of just a notes page here. It says an angle is formed when 2 rays intersect. An angle is formed when 2 rays intersect. The common endpoint is called the vertex. So look here, they've given us angle CAB or BAC, right? That's what we would call this. So over here we're naming it. Look, they've got the ray symbol written. So it says ray AB and ray AC form angle BAC. Where A is the vertex. Look at the vertex. That's where they intersect. So ray AB, ray AC form BAC, where A is the vertex. Acute angles, right, are less than 90 degrees. They're more closed, all right? I always tell students, focus on the word cute. We think little things are cute. Acute angles are little. They measure between 0 degrees and 90 degrees. Moving over to right angles. Right angles are a reference angle. And what I mean by a reference angle is that when we are talking about any angles measurement, we can use 90-degree angles, our right angles, as a reference to determine is this smaller than a right angle or greater than a right angle. So it's a reference angle. We use it to determine approximate shapes, sizes of other angles. So it's a reference angle that measures exactly 90 degrees. So if it is 91 degrees, it is not a right angle. If it is 89 degrees, it is not a right angle. Okay, exactly 90 degrees. Okay, moving on. This is obtuse. Obtuse are more open angles, right? Look how big they are, all right? They're like the fat angle, obtuse angles. They measure between, well, they're going to be greater than 90 degrees. So between 91 and 180. We should really change this one over here to 89, but that's okay because it's going to fall in between those. I don't want to put 90 here because if it's 90 degrees, that moves us to the right angle over here. Okay, so down here, they used this, has a bunch of different angles in it, and if you notice right here, there is a square angle. That square angle is SWU. see it here. In fact, let me get the highlighters again that we used in the last video. Okay, so if you have some highlighters or colors or markers you could use for this, it might help. I'm going to highlight this right angle. Okay. And over here in this chart, we're going to write that angle SWU is a right angle. So we're going to write angle SWU. Okay. We could name the same angle UWS. UWS. As long as they're in the order, right, then it's fine. So those are the same angle, just two names for the same angle. Okay, so using that right angle as a reference, we're going to look for angles that are less than 90 degrees. This is our reference. So within that, I could tell you, I know that this angle here is less than 90 degrees. So under, oh my goodness, Miss Morris. Okay, here, now you can see, I'm so sorry. So now you can see SWT, angle SWT is acute, okay? I can also tell using that reference point that UWT is smaller than 90 degrees. So I'm going to put that over here. That was UWT. UWT. Okay. I can also see that this is less than 90 degrees. If you were unsure, there's two things. Ms. Rodriguez is going to teach you how to use a protractor and you can measure it. Or you could take the corner of your paper. It is a square angle. It is a perfect 90 degrees. If I stick it in there, right, I can see that this ray S goes inside the paper, so it's less than 90 degrees. So I'm going to come back over here and put RWS. RWS is acute, smaller than 90 degrees. Okay. I can also see here UWV. UWV is less than 90 degrees. Again, you could use the corner of your paper, or after Ms. Rodriguez teaches you how to use protractors, you can use that to see that it is less than 90 degrees. So UWV. Okay. Okay, finally, let's look at obtuse angles. Obtuse angles are greater than 90 degrees. Greater than 90 degrees. We have two of them in here. Okay, we might need a darker color for this part, but I'm going to show you here. I can see UWR. UWR. If I took the corner of that paper and put it here, I could see that that U comes way out past the paper, so that tells me it's greater than 90 degrees. Okay, so I'm going to come over here to obtuse and put UWR. UWR. Okay, and the last one on here, I can see it use that right angle as the reference point, and I can see here that SWV is going to give me an obtuse angle because here is my right angle, and this goes further. It goes further down from it. Okay, so I'm going to come over here. This was SWV, and I'm going to put SWV. Okay, using this information, we're going to fill out this. So if you will get this paper in front of you and turn it upside down, we are going to write some real world examples of these. I know that my paper, right, has 90-degree angles in the corners. Our whiteboards have 90-degree angles in the corners. An index card right? See if you can think of one more example that usually look around your classroom and see if you can come up with one more example. Oh, sorry, guys. One more example of a real world right angle. Okay. Obtuse, the letter Y. In fact, the way I just wrote that Y isn't exactly obtuse, but Y's are usually an obtuse angle. So we write the letter Y. Okay. Trapezoids. Okay. Have obtuse angles. Let me think about something. Let me look around my room again. Obtuse is a little more challenging. I'll think on that one. I'll come tell your class when I come up with another example of an obtuse angle. Let's look at acute. Okay, acute. The letter A has acute angles, right? In my room, okay, here I'm gonna show you this. Look at these planters. If you looked at it this way, look at that angle. That is an acute angle there, okay? Those have the same, look at that. There's a nice little sharp acute angle, okay? See if you can come up with another acute angle in the real world, okay? See if you can think of one more to write on here. Obtuse is kind of hard, but I bet you could come up with one that's somewhere in your classroom that's an acute angle. Okay, so stick with me. We are going to fold this. Okay, we are going to fold this. This fold is a little bit tricky, so stay with me. Pause as much as you need to. Okay, where it says real world angles, I need it on its side like this. So intro to triangles is up here. Real world angles is here. Okay, and then I want you to flip it over like this. Look how I'm doing it. Flip it straight over like that. This other page is going to lay right on top of that. So if you were to fold down, you could see intro to angles is there at the top. If you were to look at it this way, you could see the rest, okay? So let's get some glue on these. Okay. Ready for some booms? We got this side boom, 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 boom. Look where real world angles are. Okay. Okay. Now let me see if I can remember how to do it. Okay. We're gonna take this bottom corner right here. Okay. We're gonna fold it. And we're gonna get this to line up with the top, okay? I'm gonna pull it closer to me so I can see. Okay, I want it nice and sharp. Okay, and then crease. So it looks like this, okay? Okay, next we're gonna fold. Okay, only one more fold. Yeah, this one's hard. Can't even remember it. When we're done folding, you're gonna be able to see this angle, and the words intro to angles. So watch, I'm gonna take this corner I just made. I'm gonna come down and across like this. Okay, like that. Okay. So when I'm done, it's this funky shape, right? But I have an angle, an angle, an angle, and an angle, okay? And then in our notebook, on the page that Miss Rodriguez has assigned to you to glue this on, okay, we got glue that goes on the back. And we're gonna glue this in. Okay. There you go. Bye, guys.